Now we're going to talk about independent and dependent events. Two events, A and B, are said to be independent if the fact that one event happens does not change the probability of the other event happening. If two events are not independent, then we say they're dependent. If two events are independent, so if A and B are independent, you can think of those events not affecting each other. Okay? They do not affect each other. They're independent from each other. Okay? If B happens, that is not going to affect the probability of A happening. If A happens, it is not going to affect the probability of B happening. The opposite of that would be that the events are dependent. They do affect each other. If B occurs, that is going to affect the probability of A happening. So go ahead and write a note to yourself. Independent means do not affect each other. Dependent means that they do affect each other. Now, how does that translate to our conditional probability? Well, the probability of A given B. So the probability of A given that B has happened is equal to the probability of A. The fact that B happened is not going to affect the probability of A happening. Okay? And so if you think about it that way, it makes sense. The probability of A, given that B has occurred, is equal to the probability of A. In other words, I don't care that B happened, it's not going to affect the probability of A. So this is just the probability of A. It is going to be the same if we go the other way around. If two events are independent, then the probability of B, given that A has occurred, is equal to the probability of B. Again, here we're saying, if we're finding the probability of B, given that A has occurred, I don't care that A has occurred. This is just going to be the probability of B. Again, why? Because A does not affect the probability of B. Now, this is going to be important because we're going to use this to determine if two events are independent. Okay? And it doesn't matter which statement you use. You could use the statement here on the left. You could use the statement here on the right. If you're trying to prove that two events are independent, you need to show that the probability of A given B is equal to the probability of A, or you can show that the probability of B given A is equal to the probability of B. Again, it doesn't matter which one you use. So my recommendation is for you to just stick to using one of the statements. Why? Because you get to select what event is going to be A and what event is going to be B. With that being said, let's go ahead and look at some exercises where we're being asked to determine if two events are independent or dependent. Okay. We're going to go back to the previous example where we're going to suppose we are rolling two dice. We're going to consider the same two events. And here I'm going to switch this just because previously we said that event A was getting a sum of 5 and event B was first rolling a 2. So I'm just going to go ahead and switch them. Again, I just want to keep the same order. It doesn't really matter. We can do it the other way around. Okay? So if we want to know if these events are independent or dependent, here's what we need to consider. If A and B are independent, then the probability of A given B has to be equal to the probability of A. So let's calculate the probability of A given B. We calculated this probability earlier. To calculate this probability, we use the conditional probability formula, which is the probability of A and B divided by the probability of B. We found this to be 1 over 36 divided by 6 over 36. When we simplified, we got 1 out of 6. Okay. So again, we did this part before. I just wanted to show you that in order to calculate this probability, we have to use the conditional probability. And that is how we found 1 over 6. Okay. Now next, we would have to compute the probability of A. And this is not something we calculated, so we might have to go back. Okay. So we need to determine the probability of getting a sum of 5. Again, here we're just looking at this event. We're not considering event B. So what is the probability of getting a sum of 5? Well, this is going to be the number of ways you can get a sum of 5 divided by the total number of outcomes in the sample space. The total number of outcomes in the sample space is 36. We need the numerator here. how many different ways can you get a sum of 5? Let's go back to the sample space. I'm going to erase here. Again, we're looking at all the possible outcomes. We're asking ourselves, how many ways can you get a sum of 5? Okay, so I see one outcome here that would give me a sum of 5. That would be 1, 4. I see another outcome that would give me a sum of 5. That would be 2, 3. There's another one here, 3, 2. And then the last one, 4, 1. And those are going to be the only outcomes where we can get a sum of 5. So we have 4 outcomes, 4 different ways that we can get a sum of 5. Okay? Let's go back to our problem here. The number of ways A can happen is 4. And again, we're dividing by the total number of outcomes in the sample space. You can go ahead and enter this on your calculator and get a decimal. I'm just going to go ahead and write 1 over 9. Again, you can get the decimal 0.1111 repeating, right? Same thing with 1 over 6. You can get the decimal 0.666 repeating. I'm just going to go ahead and round. Notice the probability of A given B is not equal to the probability of A. Let's make that remark. The probability of A given B is not equal to the probability of A. Okay? And you can go ahead and do an arrow here to indicate they're not equal. So what's our conclusion here? Well, we said if A and B are independent, then the probability of A given B is equal to the probability of A. But we're seeing that those two expressions are not equal. We're going to write, we see that the probability of A given B is not equal to the probability of A. Thus, A and B are not independent. If they were equal, then we would say that they are independent. We say A and B are dependent. Here, we're saying they do affect each other. If B happens, if you roll a 2 first, that is going to affect the probability of getting a sum of 5. Okay. Now, let's go ahead and look at another example. This time, I'm not going to give you any probabilities. Suppose you're randomly selecting a Washington State resident who has a mortgage on their home. Consider the events. A, the resident paid their mortgage this month. B, the resident is unemployed. Notice I'm not giving you any probabilities here. I mean, we can know that if A and B are independent, then the probability of A given B is equal to the probability of B. But we do not have probabilities. So let's go ahead and make that comment. We do not have information about the probabilities of the events. However, let's try to make a conclusion. Let's try to think about this. We can assume that if a person becomes unemployed, they are less likely to pay their mortgage. Okay. So we can assume that A and B are not independent. If somebody becomes unemployed or if somebody is unemployed, then they're less likely to pay their mortgage. So the probability of A, which is the resident paying their mortgage, that can be affected by the fact that B has happened. Okay? Again, here we're saying if B occurs, then the probability of A is going to be affected by that. So again, here I'm writing they are not independent. We usually don't say they're not independent. We say the events are dependent. Again, here we're saying they do affect each other. Now, there's one more question where you're being asked if two events are dependent or independent. In part C, you're going to suppose you're picking a card from a deck. You're going to consider the events A, which is picking a jack, and B, which is picking a heart. Are these events independent or dependent? So again, if you're wanting to know if A and B are independent, then you need to see if the probability of A given B is equal to the probability of A. Because if those probabilities are equal, then we know that the events are independent. So here's what you need to do. You need to calculate the probability of A given B, which can be calculated using the probability of A and B divided by the probability of B. Then you need to calculate the probability of A. Once you have a value for those probabilities, you want to see if those probabilities are equal to each other. If they are equal to each other, then A and B are independent. If they're not equal to each other, then A and B are dependent. Okay? I'm going to let you do this on your own. I'm going to ask you to give me the probability of A given B. I'm going to ask you to give me the probability of A. I'm also going to ask you for your conclusion. Are the events independent or dependent?